Here we are, ladies and gentlemen. The next step in derivative rules. Now, we talk about trig functions here today, and when you take the derivative of a trig function, what do they turn into? So if we did the difference quotient and use some complicated trig identities, we would find out things like if we did the derivative of sine, we'd get cosine. We did the derivative of cosine, we get negative sine. So on and so forth. You can read these. You need to memorize these, but don't worry. If you are doing your work and honest about it, you'll end up remembering them anyway. All right, now some little tricks to kind of help you, what I do. And if you want to pause and write them down, that's fine. I'm going to show them on the next slide anyway. Bam! Here you go. So I've got some of my little tricks here to help you out too. I grouped them together. All right, so that sine and cosine kind of go together. Secant and cosecant kind of go together. And they look similar. And tangent and cotangent go together. So I grouped them by their familiarity. That's one thing. And the other thing is I figured out that if the trig word starts with the syllable co, I always end up making the derivative negative. Derivative of cosine turns into a negative sign. The derivative of cosecant has a negative sign in front of it. The derivative of cotangent has a negative sign in front of it, whereas the derivative of sine, tangent, and secant don't have negative signs in front of them. All right, and like I said, the groupings kind of help you. If you get tangent gets secant squared, cotangent has a cosecant squared. There's some easy things that you could do to start memorizing these things. Also in the beginning, what I started off doing is just memorizing one from each of the different color boxes, and just knew that when I did like the derivative of sine was cosine, I knew when I did the derivative of cosine, I just did the other way around. I knew it needed a negative sign and just knew that it was sine. Okay, so now we're going to start using these. And got to keep in mind when we do these, our rules still apply for everything else. They're just like another rule. All right, here's the derivative of 5 over x squared plus secant x. So, oops, I made a boo-boo. I didn't get my pen ready. Hold on. Give me blue. Blue, I said. Here we are. Okay, I'm calm. Shrink down the size. Okay, there we are. All right, back. All right, so the first thing I want to do, before I do any actual calculus, so I'm going to do a little pre-calc work here. And I'm going to take that 5 over x squared and make him 5x to the negative 2. And then plus secant, just to make the calculus part of it easier. All right, so now when I take the derivative of this, you'll end up with negative 10x to the negative third, because negative 2 times 5 is negative 10, subtract 1. And now the derivative of secant was, well, I forgot already. Right from the list, derivative of secant is secant tangent. So I'm just going to write that on here. Secant x tangent x. Please put the x in both spots. It is important because if you don't have the x in there, it's implied that the tangent is in the x's location, and that's something totally different. Oh yeah, one other thing. Fix that negative exponent. Do still apply those rules of algebra civility. Okay, there's our answer. All right, let's scroll down here. I got another little answer right there. Now I've got the derivative of 2 sine squared x. Now, there was no mention of squaring a trig function, so you don't know any other way to do this just yet, other than splitting up the sine squared to sine times sine. Now, I said sine times sine, so that means we're times in, the product rule. We got to use the product rule. Now, the product rule here, I'm going to consider the 2 as part of that first sign and this sign by itself. So that's like my F and my G kind of thing. So I will have 2 sine x cosine x plus 2 cosine x sine x. All right, and because multiplication is commutative, you can actually add these two terms together to make 4 sine x cosine x. Now, you could use an identity to simplify this. I see textbooks do that sort of thing, but for our purposes and what I want you to do, you could just stop here. And if you're confused about the line above and you need a little bit more clarification, again, I said this would be like my f and this would be like my g. So this person right here, this part right here would be my f. This part right here would be my g prime. This part right here would be f prime. And this part right here would be the g, following the product rule from the past 2 days. Moving on. Oh, okay. Product rule. See? Here, this time here. Now this guy right here is the f. And this one right here is the g. So let's follow that. So, all right. So x squared plus 1. And then the derivative of secant is secant tangent plus. Now, the derivative of the x squared plus 1 is 2x. And then you have the secant x. Oh my God, I left myself all this room and the problem's done. That's it. Good. Moving on. That's it. Oh, this one looks tricky. You know why this one looks tricky? Because I've got this cosine and then I have this other product rule as part of it. Okay. All right. Getting a little crazy about it. Let's get right to it. So let's see. The derivative of cosine is negative sine. Nothing else to do there. Minus. See that minus sign? I'm just going to pull that out all together. Now I'm going to do the product rule between these two pieces right here. So I'll use a parenthesis to put that product rule in there. So we have x. Now the derivative of cosecant, I'm going to get another parenthesis, is, oh, I forgot already. What's the derivative of cosecant? There it is, negative cosecant cotangent. So, oh, great googly moogly. Let me get myself back to where it was. I said longer page and then I went way too far. Negative cosecant x cotangent x plus the derivative of the x is just 1. And then we have the cosecant x. And there we go. All right, so this one, we got so many parentheses and negative signs and stuff like that. Let's just see what we can clean up. So we have negative sine x. Now, okay, this negative sign is going to distribute to both of these terms. And so in the first go around, you'll have plus x, cosecant x, cotangent x, and then minus cosecant x. Now there's nothing else here to combine, so that's all good. Alrighty. Now, whether you realize that or not, that's a quotient rule. You're like, what, a quotient rule? Oh yeah, we could do that. Low D high minus high D low over low low. So let's do that. Low D high, so the derivative is going to equal low D high, the derivative of secant was secant x tangent x minus high D low secant x times the derivative of 1 plus tangent x. The derivative of 1 is 0, so that's gone. And the derivative of tangent x is secant squared x. And that is going to be all over low, low. 1 plus tangent x quantity squared. All right, a little bit of cleaning up here to do. You could the secant x tangent x could distribute back into that. So you'll have secant x tangent x plus secant x tangent squared x minus secant cubed. Because the secant squared times the secant, that's where the secant cubed came from. And then here's the other part right there. Just keep the bottom the same, nothing else to do. Yes, there are like identities and things you can factor and simplify this. I'm not interested in that now. All right, my last little example here, I do want to spend a minute to do because it actually borrows from something we did earlier on, the trig identities. Because one of the other reasons that we needed to learn all those trig identities is to be able to simplify these things. Now, the trig identity in particular that this guy is going to be looking at is going to be tangent squared x plus 1 is equal to secant squared x. Now, the reason why I went for that identity as opposed to any of the others was I saw that the problem had a secant squared and a tangent squared. So that's what I'm going to use. Let me just give myself a little bit of room and do a little bit of switching here. So let's see, the secant squared, according to the identity, is going to turn into tangent squared plus 1. So I'm going to say this. I said it before. I say it a lot, is that before we do the calculus, we have to do the pre-calculus. So that means the trig stuff. So that tangent squared x plus 1 is replacing secant squared. Then minus the other tangent squared. There. I've done no calculus yet. No derivative yet. I've just changed this into that. Now, tangent squareds. Look at that. They're going to subtract each other out. That's so cool. And then you're just taking the derivative of 1. Well, what's the derivative of 1? 0. The derivative of any number just turns into 0. That's right. Okay. Ladies and gentlemen, I hope you gained something out of this.